we've got a leaker here. Gonna be putting a new seal in it. I'm not a boiler guy. Circuit boards is my forte. But every now and then I gotta deal with some crusty bolts. You wanna see the most disgusting insect in the world. This is it right here. God, these things are nasty. That thing comes shooting out of a floor drain while I was taking a leak. Ugh. Alright, so if you've never seen underneath of one of those shields, there's a rubber coupler in there. And that's just so electric motors are instant torque, and that's why you need something in between that and what it's driving to kind of offset that instant torque, and that's what this rubber coupler is for. Now we do need to replace this. It's looking pretty worn out, but what we're going to do is get this slid back to get that out. Here's what these couplers look like close up. Now these bolts are very corroded, so after spraying them with some penetrating oil, I'll put the old right on them. These wrenches right here are my favorite, just a couple notches below maybe a flank drive plus, but they will not slip. What we want to do though is work them back and forth like this to try to avoid snapping them off. They are coming out hard. I'll tell you what, having high quality tools is where it's at. When you're in the trenches, they got to get you out of a jam. Man, not in focus, there we go. I love those right wrenches, they're USA made. I think the snap-on flank drive pluses might be slightly better, but not by much at all. Let me show you an open end. See that? Now, of course, the box end, I prefer to use that, but this open end, these suckers will not slip. This right here is the other thing I use on these. That works really well. Short socket would be better for higher torque, but we've got them loose now. So what I'm going to do now is take this dead blow and try to break this seal. This is a dead blow. This is not a rubber mallet. There's a big difference. Inside of here is a bunch of metal BBs, and what it does is it transfers all the force without any bounce back. So these hit by far the hardest of all of your kind of soft hammers. And so with these backed out but still in, I'm going to try to get this to break free from here. I really like these indexing pry bars. At the time I bought them, I think Gear Wrench was the only one making it, but there are a few other brands out. But just allows you to get the perfect angle, get in there and break something free. So let's start working our way around this thing and see if we can't get it to pop loose. Alright, we got that loose. Yeah, of course, we have to take all these loose too, because the impeller in here, you know, we've got to have all of this taken apart so we can get the shaft out to get that seal in place. It's loose. Wow, those are easy. I had some hard ones over here. When that happens, you want to hammer it in reverse a bit and then go back and hammer it forward a bit and then go back to reverse, and that kind of works the thread back and forth. Helps get the penetrating oil down in there and helps break it free. But when you're using an impact, don't be afraid to go the wrong direction. That can be really helpful in breaking a fastener loose. She's a squirter. Oh my gosh. I was just telling the apprentice, you have to be careful with these ratcheting wrenches, because when they have no lever, you got to watch out for this. But what you can do is you end up throwing them on there and you're backed out, and then you hit something like a frame and you can't reverse. And if you can't get back down on the thread, you got to either cut the bolt or the wrench. So with any ratcheting wrench that is non-reversible, you got to watch getting trapped. Alright, there's a couple ways we can handle this as far as getting this to break free. We can put the bolts back in and then use the dead blow. I've showed this in quite a few videos. I'm going to use my little palm nailer as an air hammer. I'll treat it a lot like a brake rotor and just go around and then try to split it with the chisel without damaging the face that the gasket needs to go on. So let's give it a shot. There's the old beast right there. Finally got her to break free. It was a combination of using the chisel to get it wedged, and then so on this side chiseling and then smacking on this with the bolts back in, or at least a few of them. And that was the ticket there for breaking that sucker free. That was a hard one to break free. I'll tell you that right now. But on to the next step. This is where impacts really shine. So if you don't know, what's going on is you have like an anvil in here that's slipping and then hammering. But what that's doing is, see, the momentum of this wheel is gonna have a tendency to keep it from rotating. And that hammering is so fast that it hammers, the wheel comes back to rest, or it comes back to its initial state of momentum. And that cycle can just go on and on. So this is an Allen down in here, and what we want to do is put the impact on it, because that'll be a lot easier. Otherwise we're going to be dealing with trying to hold this. Okay, what I'm hoping is this isn't reverse thread, but I don't see any indication. Got another great opportunity for the little palm nailer to shine. Now, I do have a puller that I think is large enough to get on this wheel, but if I take a punch and get it down in there, I might just be able to use the palm nailer to pull this turbine. So let's see how it goes. Okay, so this is the punch I'm using. This is a roll pin punch. Just happens to be the perfect cock for this hole. But get it in there. Let's see if we can get this thing to budge. No such luck on the air hammer. I've had that thing break loose some amazing stuff, but I had to get out the OTC for this one. So this is a monster puller. Should be able to handle this. Now, one thing I have to be sure of is I don't just go driving this pointy end into that, because I don't want to dick those threads up. So I got to rig up something, and then we're gonna give her the beans. Now, that's what this is for right here. This bolt that I've cut that fits in a 3/8. I don't want to go jamming that end in there either, because I don't want to dig up my socket. But this little combination right here is pretty effective at pushing those shafts out. One other thing I like doing on my pullers is I make these points actually ride on a ball bearing. Kind of takes out some of the friction, so right there just helps it spin a little better. All right, let's give it to her. Don't need two hands for this one, boys. And here she comes. Okay, here's where we're at. We've got our seal. You want to be careful not to touch those or get them dirty. You don't want grit in there grinding around in that ceramic. And we've got this shaft right here. It's normally not a big deal. I'm going to treat it just like any other bearing, any other inner race that I'm trying to get off. I'm just going to heat it up with a torch. And what that does, you're not trying to melt it or anything like that. You're just warming it up, because every 100 degrees or so you go up, it's quite a bit of expansion, and it should come right off here. So let's see what happens. All right, give her the old rotisserie chicken treatment. Woo! spinning pretty steady. Easy peasy. Alright, so she's off. Now, one thing to keep in mind is you don't want to put so much heat in there that you're cooking this bearing, but honestly, a lot of the heat is going to stay on this part and the brass. So you just want to be quick with it. It should be okay, but still smooth as silk and looking good. Alright, we want to get these surfaces cleaned up from rust, probably before we get the, you know, the seal and the sleeve and all that stuff on there. This is one of my favorite scrapers by far, made in the USA, baby. And I love this thing. It's carbide. That's one thing I use. I keep it in this hose. Keep all my cutting tools in hoses and vinyl tubing and stuff like that. Keeps them sharp. Roll around in the toolbox. This right here is great. This little M12 die grinder. Now, if you decide to get this thing, don't ever let that collar, that stainless piece right there, slip underneath of this nut, because we'll never get that little bastard out of there. Part of the function here of this nut is to lift that collar up, which helps break it free off of these. I like using the ones that are sandpaper, and then this, I think these are called Rotolocks, made by 3M. These are awesome. Also, of course, the grinder. I wish I had a flap wheel. I just don't have one. Wire wheels work okay. They're great at knocking loose the loose stuff, but honestly, kind of polish the rust that's sort of mounded up. That's where the scraper comes in handy, or something that's more like sandpaper. Alright, so once I get the scale off there, I can come in with this. It really cleans it up nice, as you can see. Nice and shiny. We're going to eat lunch right off of this now. Alright, I'm going to get the rest of this done and we'll move on. One reason this scraper works so good, it's that 90 degrees surface. And that's real important for getting the scale off and gasket material. You can just see it flying off there without scratching the face. I don't know what it is about this scraper, but it's just been by far the best one I've ever used. Alright, here's where we're at. So I got out the old ceramic seal. I got the new one in. Don't touch those and don't get them dirty. Everything just needs to be mirror clean. You don't touch this either. See that? Mirror clean. I can keep them those grimy mitts off it. Alright, so what I'm going to do is very carefully put this on. As far as getting the new brass sleeve in there, that's kind of a piece of cake. We're just going to hammer it down as far as it'll go with the socket. And then the old sleeve can be used to hammer it back the rest of the way. So now, we got a new spring. This is the old one, but all this will go on. We'll get the impeller on, and everything's going to plan so far. Which is more than I can say on a lot of days. Give it a nice coating of anti-seize, and you know, this will help with sealing some, but mainly it'll help get it apart and get the old gasket off. And if there is a next time, I doubt there will be, but just in case, I'll throw the next guy a bone. The anti-seize also helps stick the gasket in place so it's not trying to roll off there and move around as you're getting the bolts lined up. All right, looking good, looking good. Right, I got her nice and tight in there. Seals being compressed. All my anti-seize on there. Always wear gloves with that crap. Otherwise you'll come out looking like the Tin Man. But we're gonna get it back together. Trying to get ourselves a coupling. Might have to use the old one temporarily. It's not ideal, but might be what we have to do. Having a hard time finding one in stock. So now I got that one kind of lined up. Get in there. Now that's gonna line up the rest of them. It's hard to see, but this hole is now lined up pretty good. Got the valves open now. She's leak free, spinning smoothly. Well, she got another 50 years in her, I think. That's one machine conquered, many more to go. All right, let's go.
All right, you ready?
Yep.
Hold on.
You're not confident, huh? Because the new coupler's in perfect condition and has no slop, we're having a hard time getting the vibration out. So tried a few little adjustments, but I'm just not going to waste time with it. I'm going to start from scratch. I want to get the motor out of the way. I'm going to get this mounted and take some measurements, and then I'm going to try to make sure that this is basically as level as possible, or as square as possible, not really level. And I'm gonna get this as perfect on the base as possible, and then off of these measurements I'm gonna make some calculations for the motor just to start, and then from there we'll add shims and things. Where's that shim kit? Let me see it. This is what a shim kit looks like. I didn't have it with me yesterday, but you've just got an entire assortment of shims and things. This one's been pretty well abused, but we probably have enough in there still to make it work. I'm gonna make a support for the back of this whole pump assembly. I didn't realize how poorly installed this thing was to begin with. You know, I knew we had to do the seal. I just didn't, I didn't see it running. I wasn't the one out here that found this whole issue. So there's a lot of issues that I'm going to try to straighten out. Now, I prefer a portaband for cutting unistrut, but mine's buried. I'm just going to do it with the grinder real quick. And I really like these diamond blades. They work a lot better than the little zip wheels. And what you want to do with a grinder, if you don't already know this, is you never ever plunge cut and just try to work your way through the material. You score it, go back and score it, and score it, and score it. Those make your lines pretty much perfect. So I'm going to show you what that looks like, but that little first score guides your wheel through the whole process. It also keeps you from overheating your material and overheating your wheel, because you're kind of evenly distributing the heat across the entire piece that you're cutting. Keeps your wheels in good shape and just overall works out great. I'm going to do this first one, and then the apprentice is going to take over and do the rest. So this right here is my first cut down and back. Now that cut will be pretty much perfectly straight from here on out. Just doing the best I can with what I have on hand, but it turns out that the entire weight of this assembly just sags down on this end. So I got a piece of strut on there because our hangers, there's one right there. To be honest, and maybe someone can answer this question. I don't even think this should be code, really. I don't see how a hanger on insulation does anything at all. But I've got this now, you know, mounted really well to this plate. Now what I don't know if this plate is level, and really I'm not concerned with it. This is now fixed. And so what I want is these center points to be at the same height. And then when I get this together, I want to make sure my reveal all the way around is the same. And that should basically mate those two things perfectly square to each other. So here's our shaft sizes. This is in millimeters because of, you know, my caliper being millimeters. But so those are a radius, and then here's the distance from the top down, which means from the bottom to center point is here. So we take this point here and add one radius to it, and now we've got the measurement from the top down. And it turns out that I need to bring this motor up the thickness of just a few shims, like right around in there. And then the center of the shafts will match, and then we'll get the alignment right by measuring this distance here and making sure it's uniform all the way around. Okay, so got the alignment done. The first thing I did, based on the math, is bring the shafts up to the same height. Now there's a lot of different planes in which this has to be aligned. These can't be skewed off from each other, so one can't be one way or the other. They have to be lined that way. They have to be aligned height-wise, and they have to be aligned at the same angle, so you can't have one of these cocked one way. So basically, after the height was done, worked on getting the angle correct, so had to raise the back up because my gap was bigger up here than it was down here. So you raise the back up for that, and then shifted this like that until we got the exact same measurement here and here. So now these two little coupler hubs are perfectly aligned all the way around. Alright, go ahead and hit that power. That little baby is smooth as silk now. Perfection, almost. You can only get this old piece of shit so good, but we got it pretty damn good. Okay, nice. Watch this is pretty cool. Okay, go ahead and hit it. It's a stainless steel flex joint in there, but now that's what you call fighting a machine. We conquered that little bastard. Off to the next one.